Welcome back to Spring Into Math 8. Today's topic is similar triangles. Let's go ahead and get started. So we've examined types of interior angles, exterior angles, triangles, and polygons. Now let's examine how we can tell if triangles are similar based on the concepts we've just covered. And you should know that deciding whether triangles are similar or not is a very basic, short lesson. So angles of similar triangles. Two angles in one triangle are congruent to two angles in another triangle. Then the third angle is also congruent, and the triangles can be classified as similar. Now what I mean by this is shown on our image below. We have a 95-degree angle, a 65-degree angle, and we're listed here as that's triangle A. Now triangle B, which looks a little bit larger, also has the same measurements for their angles, 95 and 65. Based on that, we can say that because those two are the same measurements in both triangles, that we have to know that the third angle is also similar. So that is the theory or the proof behind this. When two angles and two triangles are the same, the third angle is automatically the same as well. So take a look at these triangles right here. We have triangle A, triangle D, and triangle G. Now, triangle A is the smallest of these three, and triangle G is the largest of the three. Based on this, without looking at any of the angles, most of us would say that triangle G has bigger angle measurements than triangle A just because it looks like a larger image. However, in this particular case, that is not true. We can say that triangle A, which has a 30-degree angle and a 60-degree angle, can also be shown in a different version in triangle G, which also has 30 degrees and 60 degrees. Based on our definition or our theorem of our proof here, that when we have two of the same measurements inside of a triangle for interior angles, the third angle is also going to be the same. So triangle A has a 30, 60, 90 degrees measurements for our triangles, and triangle G also has 30, 60, and 90 degree angle measurements. Now 30 plus 60 degrees makes 90 degrees, and 90 plus 90 makes 180. We just want to double check to make sure that these are triangles, and we always know that triangles add up to 180 degrees. Let's take a look at triangle D for a second. That's the middle triangle here on our image. Now, you can choose to compare it to triangle A or triangle G. It's really up to you. I'm going to go ahead and compare it to triangle A for this instance. So I can see that the top angle is 30 degrees. Triangle A has a top angle of 30 degrees as well. So we're 1 for 1 here. Now, triangle A also has a 60-degree angle measurement. So does triangle D. They have 60-degree angle measurements in the same spots. Now, based on our theory or our proof that we talked about, when the two angles are the same inside the two sets of triangles, the third angle is automatically the same. And in this case, you can see that the last angle, which is 90 degrees, is represented by that little square in the bottom corner. So we also have similar triangles. We can say that all three of these triangles on this page are similar. They are different sizes, yet they are similar. So here's another way to look at this. We've got two different triangles here. We've got a kind of a tan triangle and a blue triangle. We've listed here that we have a 72-degree angle and a 35-degree angle. And this other triangle over here in blue also has two of the same measurements. But if you look close at these triangles, they are different types of triangles. They're not exactly the same. They've kind of been rotated and extended a little bit to give them a little bit of a varying size. So let's just go ahead and try out our theory or our proof. So I set up an equation here for us to work with. It says x plus 72 x plus 72 plus 35 equals 180. Our equation is nice and set up at this point. Let's go ahead and solve with what we know. Well, 72 plus 35 is 107. So I have x plus 107 equals 180. So far, so good. Now we need to subtract 107 from both sides of our triangle. So when I subtract 107 from 180, I get 73. So I can say that the missing angle in my tan triangle is 73 degrees. That's the answer for that third angle. So now our triangle here, our tan one, has all three measurements: 72 degrees, 35 degrees, and 73 degrees. And when I add those together, I get 180. Now, based on our theory and our proof we've discussed many times so far, when I have two of the same angles on one triangle on the interior, and they have the same measurement interior angles in the second triangle, which is in blue here, we can go ahead and assume that that third angle is the same. So I have matching 72-degree angles, matching 35-degree angles, and we just solved that missing angle for our first triangle in tan here, which we found that missing angle was 73 degrees. So we can say with confidence that these triangles are similar because of our theory or our proof. In review, if two angles in one triangle are congruent to two angles in another triangle, then the third angle is also congruent, and the triangles can be classified as similar. Happy solving! Catch you next time.